All right, well, this review is going to get you ready for your TEKS test. Your TEKS test is going to cover the entire semester. The first section of the review, numbers 1 through 3, all have to do with triangles. Because we're dealing with triangles, you want to make sure to go ahead and put your calculator in degree mode the minute you see a triangle problem. So I'm going to go ahead and put it in degree mode. The next thing you need to know are these formulas that will be written on your test and what they do and which ones they are. This first formula right here is called your law of sines formula. You can find angles or sides using this formula. In order to use this formula, you need an angle and its opposite side. This formula down here is our law of cosine formula. This is usually used when you have side, 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 or if you have a triangle with an angle and not an opposite side. This formula right here is used to find the area of a triangle. And this one right here, very familiar. This is our Pythagorean theorem. So on number 1, it says, find the indicated measure in each triangle. I'm just going to focus on 1A. So on 1A, the first thing I notice is it's a right triangle, and they want me to find theta. They want me to find this angle right here. So you could use SOHCAHTOA because it's a right triangle, or because I have an angle and the side opposite, and I'm looking for an angle and I have the side opposite, I can use law of sines. So I'm going to use law of sines here. So in order to use law of sines, I need a given angle. So I have 90, so sine of 90 goes on top. The side opposite 90 degrees goes on the bottom. I'm looking for this angle right here. We'll just call it sine of B. And the side angle, the side opposite that angle is 8. From here, we're going to do what I think we called it the butterfly. We're going to multiply the two numbers that are diagonal, and we're going to divide by the number I didn't circle. So in my calculator, remember we've already changed it to degree mode. I'm going to go multiply sine of 90 times 8. And then I'm going to divide by 14. And we're going to get this decimal. Now remember, we're looking for an angle. And anytime you're looking for an angle, you have to remember to use the second button to find the angle. Since I'm doing law of sines, I'm going to hit second, sine, and then I want that answer to pop in here. So we're going to do our second answer button. So that's your second and your negative. You'll see it pops in there the word answer, and then it tells me 34.8 degrees. So my answer is 34.8 degrees. Okay. The next problem I'm going to look at with you is number 2. Number 2 is a navigation problem. So before we start the navigation problem, there's a couple things we have to remember. That north is 0 degrees, and it's right up top. To the right, we'll have east, which is 90 degrees from the north. At the bottom, we have south, which is 180 degrees from the north. To the left, we have west, which is 270 degrees from the north. So it says that there's a private plane that flies for 1.3 hours at 110 miles per hour. And they remind us at the bottom, to find the distance, we simply multiply the rate times the time. So the distance that I traveled right there would be 1.3 times 110 miles per hour. So I went 143 miles. And I went 143 miles with a bearing of 40 degrees, which is what this picture shows right here. I like to draw my own pictures, so I'm going to go ahead and start from scratch. If this is 0 degrees and this is 90 degrees, 40 degrees is going to be about right there. And I'm going to label it 40 degrees. And I traveled 40 degrees for 143 miles. So the length of this line is 143. It then says I turn. Because I turn, I'm going to draw myself a new compass. And it says I turn and continue another 1.5 hours at the same speed, meaning 110 miles per hour. So I do the same thing, but this time I do 1.5 times 110, and I find out that I went a distance of 165 miles. So this time I went 165 miles, and I turned 130 degrees. So again, this is 0, this is 90, down here is 180. So I need to figure out how much more do I need to go from 90 to get to 130. I would go 40 more. So this whole distance is 130, but that little wedge right there is 40. Okay? And I went along this line 165 miles. They want to know what is the distance from where I started to where I am now. They want to know x. Well, I know the length of this side is 143. I know the length of this side is 165. And I actually know this angle right here. If this little wedge is 40, that means this wedge right here is 50. Because I have 40 degrees right here, and we know something called alternate interior angles, this is also 40. So this entire angle right here is 90 degrees. So I have to decide which formula to use. Should I use law of sines or law of cosines? Well, I do have an angle, but I don't have the opposite side, and they didn't give me any other angles, so that means I'm going to have to use law of cosines. So law of cosines says to find the missing side, we'll call this C. We're going to square A, I'll call that A. We're going to square B, we'll call this B, minus 2 times A times B times cosine of C. Well, cosine of C would be this angle right here, which is our 90 degrees. So I'm going to go plug this in. So C squared equals, again, I'm using the law of cosines formula up here, 143 squared plus 165 squared minus 2 times both those numbers times cosine of C, which is this angle right here, and the whole angle right there is 90 degrees. And I'm going to type that whole thing in my calculator, and that's going to give me C squared. So here we go, 143 squared plus 165 squared minus 2 times 143 times 165 times cosine of 90. And that gives me 47674. Now that's C squared. I just want C, so I have to take the square root of it. So the square root of, I'm going to use my second answer button again, is 218.3. So we're going to approximate 218 miles. Okay. Number 3 says, given triangle DEF, determine the degree measure of angle D. So they want me to find this angle right here. They give me 3 sides, and then I want you to go ahead and add this extra bit of information. I'm going to go ahead and tell you that this angle in here is 96.4 degrees. So this is going to work a lot like number 1. I have an angle and an opposite side. I'm looking for an angle, and I know the opposite side. So I'm going to go use law of sines again. So I'm going to take the angle that I know, sine of 96.4, put it over the opposite side, which is 70. I'm looking for angle D, so I'll call it sine of D, and sine of D is opposite 60. Just like earlier, we're going to multiply these two together and then divide by the 70. So here we go. We're still in degree mode. I haven't changed anything. So sine of 96.4 times 60, enter, divided by 70. And again, I get, oops, let me try that again. So sine of 96.4 times 60 divided by 70. And again, I get this tiny decimal. Well, remember, I'm looking for an angle. And every time you look for an angle, you have to remember to use the second button. Because I'm doing law of sines, I'm going to second, sine, second, answer. So the angle I'm looking for is 58.4 degrees. So angle D is equal to 58.4 degrees. Okay, so that takes us through everything that we need to know about triangles for the TEKS test. To know if you're actually listening to what I'm asking you to do, if you please go to the top right-hand corner of your page and write the word period, and please fill in the blank right there. That'll get you some extra points. If you are in my first, third, or fifth period class, if you will go to number 1 and put a star directly to the left of it. If you are in my second, fourth, or seventh period class, please go to number 3 and to the left of number 3, put a star. The next thing we're going to talk about is vectors. This is the next thing we talked about this year. Vectors always have a magnitude and a direction. Number 4 says, for each of the vectors below, find its magnitude. In order to find the magnitude, you have to know the formula. They will not give you this formula on the test. It's something you need to know. So to find the magnitude, we're going to take the square root of a squared plus b squared. I'm going to focus on just doing one from each section. I'm going to do 4a. To find the magnitude of a, I have to take the square root of a squared plus b squared. you need to know that A is the number in front of I and B is the number in front of J. So we're going to have the square root of negative 5 squared plus negative 12 squared. Well, negative 5 squared is 25. And negative 12 squared is 144. And 25 plus 144 is 169. And the square root of 169 is 13. So in order to find the magnitude on your test, make sure you know that A is the number in front of I, B is the number in front of J. You're going to square A, square B, add them together, and take the square root. You would do the exact same thing for B and C. On number 5, it says given the vectors graphed to the right, so they're talking about these vectors right here, write each of the following in terms of I and J. I'm going to focus on letter A. A wants me to add vector A and vector W and vector V. In order to add these two vectors, first thing I have to figure out is the magnitude and the direction. So I'm going to go write W, and then I'm going to go write V, and then I'm going to add them together. So what we need to remember is that your A is going to tell you how far you went to the right, and your J is going to tell how far you went up or down. So I'm going to start right here at the tail, or the tip, whatever you decide to call it, and I went right 2, so that's positive 2I, but I went down 1, 2, 3, so my J is negative 3J. I went to the right 2, so I got 2I, I went down 3, so it's minus 3J. For letter V, again, I'm going to start right here, and I'm going to go towards the arrow. I went left 1, so negative 1I, and I went down 1, 2, 3, 4, so negative 4J. When you're asked to add, subtract, or multiply vectors, you do it term to term. So 2I plus negative 1I would simply be positive I. You don't have to write the 1 there. It's up to you. Negative 3J plus negative 4J would give you negative 7J. So the answer is I minus 7J. You would do the same thing for B, but we'd subtract. For C, you'd multiply V by 2, and then you'd add the W to it. The next section of the review is wanting me to convert from polar coordinates to rectangular coordinates. So this whole section is about polar. And before we start anything that has to do with polar, one thing we want to go ahead and do is we want to go to mode, and I want to be in degree, and I also want to be down here, instead of being in functions, I want to go over here to polar. I also want to go to my window, and I want my window, since I'm in degrees, to go from 0 to 360, and I want to count by 5s. Okay. Another thing we need to know about polar coordinates is that R is going to be your radius, and it's usually written first. And your second coordinate is your theta, and it can be in degrees or in radians. Since I just set mine to degree, I'm going to keep mine in degree mode. So on number 6, A, B, and C, they want you to convert from polar to rectangular, but I'm going to change the directions. All I want you to do is go graph this point, and then I want you to rewrite that point 3 different ways. So the first thing we need to remember is that 3 pi over 2 is right down here at the bottom. So this is 0, pi over 2, pi, 3 pi over 2. So you always go find your angle measure first. So my angle measure is 3 pi over 2. And then I'm going to go out a radius of 4. So I'm going to count out 4 concentric circles. And because it's a positive, I'm going to count 4 towards it. So 1, 2, 3, 4. So if I ask you to graph this point, you go to 3 pi over 2 first, which is at the bottom. And then I'm going to go count 4 circles towards that angle. What I would like you to do is rewrite that point 3 different ways. This says I want my radius to be a negative 4. So if my radius was a negative 4, what would my theta need to be in order to be in this same spot? Well, if it's a negative, it means I moved away from the angle. So what angle could I move away from and still be in that same spot? Well, if I was at pi over 2 and I moved 4 away, I would end up in the same spot. So it's pi over 2. The next thing they want me to do is they want me to rewrite it with a positive radius. So they want me to leave it as positive 4, but they want my theta to be negative, meaning they want me to go the opposite direction. So if I was going to go this direction instead of going around the circle, then I would think, okay, if you go this direction, my angle's negative, and I only went one quadrant, so I went negative pi over 2. The last thing they want me to do is they want me to go in a negative direction, and they want my radius to be negative. So I need a negative 4, so I'm going to go 4 away from something. So I'm still going to go away from this, but they want me to write it as a negative. Well, if this is negative pi over 2, this is negative pi, this would be negative 3 pi over 2. So on your TEKS test, not only are they going to ask you to convert, but sometimes they're going to ask you to rewrite things to see which ones are equivalent and which ones are not. Okay, so now let's go to the page. And at the top of the page, I wrote our conversions. If they ask you to go from rectangular to polar, we're going to use these equations. If they give you r and they give you theta, you're going to find x by saying r times cosine, and you're going to find y by saying r times sine. If they give you x and y, and they want you to find r and theta, r is going to equal x, the square root of x squared plus y squared, and the tangent of theta will equal y over x. I'm going to go focus on number 8. Number 8 wants me to graph the following polar equations. If you have already set your calculator up like I told you, with degree, polar, and your windows from 0 to 360, simply go touch the y equals, and you'll notice that they all say r equals now. So I'm just going to go do letter B. It says r equals 3 sine 4 theta, and I'm going to go hit graph. And it looks like I see a flower that has 2 petals in each quadrant. So it's a flower with 8 petals. So if I asked you to graph that, we're going to have a flower with 8 petals. There's 2 in each quadrant. And there you go. Now, again, the TEKS test is probably going to be multiple choice. So you're going to be able to type these in your calculator and then decide which one of them match. So as long as you know how to set your calculator mode and window up, you shouldn't miss this. If you're in periods 2, 4, or 7, periods 2, 4, or 7, go put a heart beside number 8, to the left of number 8. The next section is all about exponential and log functions. Number 9 wants me to solve the following. These are all exponentials. You simply get like bases and then solve for x. 10 through 12 are all word problems that have to do with exponentials. I need you to pause the video and take a moment to write this right here where I have it. So you're pausing the video and you're writing this word problem. Okay, so you've unpaused it now. The population of a certain bacteria doubles every hour. Given the initial population is 135,000, write an equation that represents P, the population after T hours. When you're asked to write a problem like this, you did this in Algebra 1 and Algebra 2. However, we did not do a lot of it this year. Anytime you're going to write a growth or decay formula of exponential, you're going to start off by writing the initial value, so 135,000, and then you're going to write your growth rate. So it says that I'm doubling, so my growth rate is 2. If I was tripling, I'd write a 3. If it was a half-life, I'd write a half, and we're going to raise it to whatever we're doubling. We're doubling every what? We're doubling every hour, and they want me to use T to represent hour. So this equation would represent the population of a bacteria that has an initial population of 135,000 that doubles every single hour. For 10, 11, and 12, you would also just plug into these formulas. You'd use your calculator. Remember that A is not, those are your initial values. R is your rate. Remember to write those as decimals. T is your time. It's usually in years. And N is the number of times that you compound. Remember, quarterly means 4. Monthly is 12. Semi-annually is 2. Yearly would be 1. Okay, so let's go down here. And so this was exponential for number 9. Numbers 10, 11, 12, and the one I added were all about word problems. Let's go look at 13 through 15. These all have to do with log expressions. And number 13 wants me to simplify log expressions. So there's a couple of rules we have to remember. If you're adding two logs, you can rewrite them as multiplication. If you're subtracting two logs, you can rewrite it as division. And if you're multiplying by a number out front of a log, you can rewrite it as an exponent. So on A and B, they want me to simplify, meaning they want me to write the word log one time and one time only. So I'm going to write the word log. There's a plus sign right here, so I'm going to multiply these two. There's another plus sign, so I'm going to multiply again. And because there's a number out front, it's going to turn into an exponent. So when I rewrite this, it's going to be log of m times n to the third, because that 3 became an exponent, times p. Notice you only write the word log one time. So they might also write it like this, m n to the third p, and not write the little time signs, and that's fine too. On letter B, it's very similar. There's a 2 out front, so I know it's going to become an exponent. Because there's a subtraction sign, I'm going to have division. And because there's a plus sign, I'm also going to have multiplication. Again, we only write the word log one time. So I have log of c squared divided by d times e. So if I ask you to rewrite B and simplify it, again, the 2 out front, because we're multiplying, becomes an exponent to the c. Subtraction means to divide, and addition means to multiply. On the 14, A, B, and C, they want you to write the log expression to represent the value of x. This is where you just log both sides. Number 15, we're going to actually go do this one together. They want to know which one of these is not equivalent. If it's not equivalent, it won't be in one of my solving steps. So by doing 15, I'm also telling you how to do number 14 above. So let's see. The first thing I'm going to notice is I can't get like bases. So I'm going to take the log of both sides. So log 7 to the x equals log of 12. Well, that's right there, so that's actually true. Because it was an exponent, I can go reverse and I can bring it out front. So log x times log of 7 equals log of 12. Well, that's what this one says right here, so that one's true. To get x by itself, I'm going to divide both sides by log of 7. So x equals log of 12 divided by log of 7, which is right here. So the only one that's not equivalent is letter C. Something else I don't ask you to do on the review that's on your test is how to graph a log function. So over here to the right, just like I did, put 2 little stars, and let's go add these two. So go pause the video and go write these in. Okay, so your video should be unpaused now. So I'm going to go back to mode, and I'm going to change everything back to where it usually is, back to radians and back to function. And now when I hit y equals, I see a y equals, and I'm going to go graph negative log of x. Now don't worry about the base that they have right here. That's not going to really affect the general shape. So negative log of x. So if I were to graph that, it would look something like this. Okay, and they also want me to graph log of negative x. So I'm going to go back to my y equals, and I'm going to type in log of negative x, and I'm going to graph that one. So it's very similar. So when they ask you to do this on your TEKS test, simply go to your calculator, make sure that you're back in function mode, and you're back in radians, and then go to your y equals and type in your 2 equations. That really shouldn't be a big deal. If you are in my first, third, or fifth period class, please go draw a heart to the left of number 13. To the left of number 13, if you're in first, third, or fifth, please go draw a heart. The bottom section, 16 through 21, is all about sequences and series. And we talked about arithmetic and geometric. Arithmetic is when you add something over and over and over. And we usually have the letter D every time we talk about arithmetic. Geometric is when you multiply something over and over and over to get the next term, and we have what we call a common ratio. So in this section, they just want to know, are you adding to get something over and over and over? If you were, it's arithmetic. Or are you multiplying to get to the next term? If you are, it's geometric. On 17 through 21, they want you to use these formulas that they will provide for you in order to get whatever they ask you for. So let's review. These 2 formulas over here on the left will help me find term numbers. This first formula has an N and a D in it, so that's my arithmetic. This second formula has an R in it, so that's my geometric. These last three formulas will help me find the sum of sequences or series. This first one is a arithmetic. The second one is a geometric, and this is an infinite geometric. So again, I'm just going to focus on a few problems in each section. So let's go look at number 18. A tile layer is creating a design for a bank lobby that is the shape of a pyramid. The first row of the design has 1 tile. The second row has 3 tiles. The third row has 5 tiles, and so on. How many tiles will be in the 10th row? Okay, well, they're asking how many. So because they're asking for how many will be in a specific row, they're asking for the number of terms in that row. So I'm going to go write out my pattern here. I have 1 tile in the first row, 3 in the second, 5, and so on. So one thing you could do is you could go count out 10 times if you wanted to and figure it out that way. Or I can decide whether it's arithmetic or geometric and use one of these. So what am I doing to get from 1 to 3 to 5? Well, I'm adding 2. So this is arithmetic, and my D is equal to 2, and they want to know how many will be in the 10th row. So I'm going to go use this formula right here. So A10 equals, that right there means the first term, plus N minus 1, N is my 10, times D, and we said these are all increasing by 2. So to find out how many are going to be in the 10th row, I would simply go type in 1 plus 10 minus 1 times 2. We find out there are 19 tiles in the 10th row. Again, if you didn't want to use the formula, you could just go write this out until you got to 10 and keep adding 2 each time until you got to the 10th row. Number 19 says, given the sequence 5, 15, 45, and 135, find the following. I'm going to go focus on B. B wants me to find the sum of the first 8 terms. So before I can figure out whether or not I should use this equation or this equation, I have to decide, is it arithmetic or geometric? I know I'm using one of these because it's a sum. I know I'm not using this because it's not infinite. So what am I doing to get from 5 to 15 to 45 to 135? Am I adding or multiplying? Well, I'm multiplying by 3. That means it's geometric, and my R is equal to 3. So I'm going to use this formula up here. So it says the sum of the first 8 terms is equal to the first term, which was 5, times 1 minus 3 to the n. Well, n is 8, over 1 minus 3. And you're just going to go type that in your calculator. And I like to type this in a couple steps. So I'm going to go type in the top first, 1 minus 3 to the 8th. And don't worry about that it's a negative right now. Divided by 1 minus 3. Notice I put it in parentheses. And then I have to take that answer and multiply it by 5. So we find out that the total sum of the first 8 terms is 16,400. All right, the next one I'm going to go look at is number 21. 21 wants me to write the series, and they give me something called sigma notation. When they give you sigma notation, they usually give you an argument right here, and all you have to do is start where they tell you to start and end where they tell you to end. It tells me to start at 1 and end at 5. So I'm going to have 1 to the 3rd plus 2 to the 3rd plus 3 to the 3rd plus 4 to the 3rd plus 5 to the 3rd. They didn't actually ask me to find the sum. They just told me to write the series. So 1 to the 3rd is 1, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd is 64, and 5 to the 3rd is 125. And that's it. If you're in my 1st, 3rd, or 5th period class, 1st, 3rd, or 5th period class, to the left of number 21, please go draw a smiley face. If you are in my 2nd, 4th, or 7th period class, go to number 18, and to the left of number 18, go draw a smiley face. The next section of our review has to do with polynomials. When we talked about polynomials, we had even polynomials and odd polynomials. Even polynomials, if they were positive, had an end behavior where both went up. Odd polynomials, if they were positive odd, the right arm went up and the left arm went down. We also reviewed when doing polynomials that the roots and the zeros are the same as the x-intercepts. And if I have the x-intercepts, I can find any factor. I also learned about something called multiplicity. If it had a multiplicity of 2, 4, 6, 8, it touches at the x-axis. But if it had a multiplicity of 1, 3, 5, 7, and so on, it actually crossed over the x-axis. So when we're looking at 22, it says graph each of the following functions and identify the requested information. You're simply going to type these in your calculator. Zeros again mean x-intercepts. Your relative maximums and minimums mean the high and the low points. Your range is the y values you're using from bottom to top, and your domain are the x values you're using from left to right. So again, you just type this in your calculator. On number 23, it actually asked me to go find the roots. And again, we said roots just mean x-intercepts. So I'm going to make my life easy and simply go type this in. So 3x to the third plus, oops, gotta remember to arrow out, plus 17x squared plus 18x minus 8. So I'm going to type that whole thing in my y equals, and then I'm going to go hit graph. And remember, roots are x-intercepts. And it looks like I touched 3 times. I touch over here at the negative twice and over here at the positive once. So I'm going to go to my table, and I'm going to look in the negatives first. Ooh, at negative 4, 0, I have a root. And at negative 2, 0, I have a root. And then I know I have another one over here, and I know it's positive, and I know it's less than 1, which means it's a fraction. So in order to find that last one, I'm going to remember that we talked about something called possible zeros. And what we did is we took the factors of the last number and we divided it by all of the factors of the first number. So we had plus or minus 1, 2, 4, and 8, all divided by plus and minus 1 and 3. And this is going to tell me what my fraction could be. So 1 divided by 2, 4, and 8, I already know those two. I need to see, is it 1/3, 2/3, 4/3, or 8/3? So I'm simply going to go to my table, second window, and I'm going to first go type in 1/3. And if that gives me the 0, I'm done. Hey, that's the one that gave me the 0. So my last 0 is 1/3, 0. Now again, remember your test is going to be multiple choice most likely, so you can actually go look at each of the answer choices in your tables. On number 24, they asked me about roots. Again, those are just your x-intercepts. They asked me about the factors. Remember, your factors are the opposites of the x-intercepts. They ask you to write an equation, and they ask you to also write it in expanded form. That means to FOIL. I want you to go add part E. E wants you to complete the end behavior statement. As x goes off to infinity, so as I move to the right, what does my function do? Does it go up or down? Well, as I move to the right as far as I can go, it's going to go up to positive infinity. As my x's go to the left, what do they end up doing for the end behavior? The end behavior says as I go to the left, my function goes down. Okay, let's go ahead and turn the page. So we're still talking about polynomials on the back. On number 25, it says use the provided graph of the polynomial function to complete the statements in the questions below. So I'm going to go look at letter B. I know the leading coefficient is either a positive or a negative. Well, because both arms are going the same direction, I know it's even. Because they're both going up, I know it's positive. So as x goes off to positive infinity, the function also goes off to positive infinity. C wants me to write the possible equation. So this is going to have to do with my factors. So it looks like I'm going to go find all my x-intercepts, and I have 3, so I'm going to have 3 factors. You always write the opposite. So if I have an x-intercept of -5, I write x plus 5. Because I actually went through the x-axis, this needs to be an odd number. So it can be a 1, a 3, or a 5. I'm going to leave mine as a 1. The next place I have an x-intercept is at -1. Again, I write the opposite, and again, I went through. Because I went through, again, it has to be odd, so it can be 1 or 3 or 5. I always pick the smallest one. This x-intercept is +5, so I have to write x minus 5. And this time, I didn't go through the x-intercept. I touched it, and then I went back. So it has to be even. So 2, 4, 6, or 8. Again, I like to pick the smallest one, so I'm going to pick 2. Letter E says solve the inequality where the function is greater than 0. I want you to change that to be greater than equal to 0. So I want to know, where is this graph always bigger than or equal to 0, which means where is it positive? So I know my graph is positive everywhere that I'm highlighting. So this is above 0, this is above 0, and this is above 0. And those are the intervals that I'm going to write. So this interval goes to the left forever, so from -infinity to -5. Because I can actually equal 0, this is going to have a bracket. You can never equal infinity, so it's going to be a parentheses. And then I go union, and then I pick back up at the 1, and it goes from -1 all the way off to infinity. So these are the x values where my graph will be above or equal to 0. The very last section that we're going to focus on is 26 and 28 and through 28, and these all have to do with rational functions. And when we covered rational functions, we had 1 over x and 1 over x squared. We talked about vertical and horizontal asymptotes, we talked about domains, we talked about ranges, we talked about holes in the graph, long run behavior, short run behavior. So on number 26, I'm only going to focus on what they call a removable discontinuity. And that just means, where is there going to be a hole at? And there is only going to be a hole if you have something on top and bottom that actually cancel out. So I'm going to go rewrite this as x plus 3, x plus 1, and because it's squared, I'm going to write x plus 1 again. On the bottom, I've got x plus 1 and x minus 4. So because I have an x plus 1 and an x plus 1 on the bottom, this graph is going to have a hole. Okay? So it's going to have a hole right here. To find out what the actual hole value is, the first thing you're going to do is decide what would make this equal 0. What would make x plus 1 equal 0? And you would tell me it's -1. And then you're going to go plug -1 into everything that's left to get the y value. So you go plug -1 in right here, -1 plus 3 times -1 plus 0. Well, -1 plus 0 is going to be -1. And, okay, I had that wrong. If I plug in a -1 right here, -1 plus 1 is going to give me 0, my fault. And 0 times whatever I get here is 0, and 0 divided by anything is 0. So my hole is going to be at -1, 0. Okay, so that was kind of a hot mess. So let me say that again. So the first thing you're going to do is figure out what cancels. And then you're going to go look at what you have left, and everything you have left, I went and plugged in a -1. So I have -1 plus 3 times -1 plus 1 over -1 minus 4. So up top, we have -2 times 0, which is 0, and 0 divided by anything is 0. So the most important thing to get from all of that is you're going to have a hole if something on top and bottom disappears. 27 asks you to simplify the numerator and the denominator, asks you for vertical and horizontal asymptotes, asks you for x-intercepts, and asks you for end behavior. All of that can be found by typing it in your calculator, so I'm not going to stress about that. On number 28, I'm going to look at letter B and C and talk about how to type them in your calculator and what the graphs might look like. So this first function right here, if you're going to type it in your calculator, you would go to your y equals, and you would type in parentheses 1 divided by x, close parentheses, minus 1. So this is going to be a 1 over x graph that simply shifts down 1 unit. So it would look kind of like this if I was going to graph it. My vertical asymptote doesn't change at all. My horizontal asymptote went to -1. The right side is up, and the left side is down. There you go. That's the graph that matches. The second graph is really similar, but it's not a 1 over x, it's a 1 over x squared. And this is the one I always say, hey, it looks like the volcano. So we're going to have parentheses, 1 divided by parentheses, x plus 2, close them, squared, close parentheses, minus 5. So this is going to be a volcano that goes left 2 and down 5. There you see it went left 2 and down 5. So I'm going to go do a little sketch of that. My vertical asymptote went left 2, and then I went down 5, 2, 3, 4, 5. And because it's the volcano, it looks like this. The x squareds, they do the same thing on both sides. Okay, if you are in my first, third, or fifth period class, at the bottom right-hand corner of the page, please go write your initials. If you are in my second, fourth, or seventh period class, at the bottom left-hand side of the page, go write your initials. So first, third, and fifth, the bottom right-hand side. Second, fourth, and seventh, the bottom left-hand side. If you were able to follow along and get my little bonus questions, congratulations.